Hi, my name is Anna Marie Picarello, and I'm going to talk about combustion reactions and hydrogen fuel cells. Alright, so a combustion reaction is the scientific word for burning. In a combustion reaction, a substance reacts with oxygen from the air. Combustion reactions happen at high temperatures and transfer energy to the surroundings as light and heat. This is why you see flames when things burn. Alright, so I'm going to talk about combustion in our everyday lives. One important combustion reaction is that of methane. Methane reacts with oxygen from the air and produces either a hot blue or an orange flame. The energy that the reaction produces can be used to heat water, cook food, generate electricity, or even power vehicles. And this is often how we create energy for our homes. Alright, the products of methane combustion reactions are compounds of oxygen called oxides. The products of this combustion reaction are oxides of carbon and hydrogen. The names of these oxides are carbon dioxide and water. And you could see in the reaction here below and the molecules. Alright, so I'm going to talk about the entropy, enthalpy, and spontaneity. Enthalpy of the reaction is negative, meaning that the reaction is exothermic. The entropy of the system of the reaction decreases, and entropy refers to the messiness of molecules. Alright, so this reaction is also spontaneous at approximately 600 degrees Celsius. Alright, next I'm going to talk about spontaneous hydrogen fuel cells, and this is an alternative way to create energy that is more environmentally friendly. Alright, so a hydrogen fuel cell is an electrochemical cell that uses a spontaneous redox reaction to produce current that can do work. The net reaction is exothermic. Combining the two half-cell potentials for the electrochemical reaction gives a positive cell potential. Alright, and you can see in the demonstration of the reactions over here, you could also see that Gibbs free energy is negative, meaning that the reaction is spontaneous. Alright, so you could see the hydrogen fuel cell here, how hydrogen is entering here and becoming H2, and then water is one of the products over here. So based on the enthalpy and Gibbs free energy for the formation of water from hydrogen to oxygen, the efficiency of a hydrogen fuel cell is nearly 80%, which is much greater than the percent efficiency of methane combustion. Close this. A major problem with hydrogen fuel cells is the source of hydrogen, the quantity of H2 in the atmosphere is very low, so it must be produced, so it's very costly. Alright, so for my person, I'm going to be talking about Esosha Cave. Alright, and her education, she has a bachelor's in science from Franklin W. Olin College of Engineering in 2006, a master's in science in 2011, and a PhD in 2015 from Stanford University. Her current position is she's a co-founder and chief science officer of Opus 12, which is a startup company specializing in recycling the greenhouse gas carbon dioxide into valuable chemicals. So it would take the harmful products of the methane combustion reaction and convert it into something new. Alright, so more about Opus 12. Opus 12 makes reactors that use electricity and water to convert carbon dioxide into useful chemicals. The key to the company's electrochemical system is a unique ionic polymer membrane electrode. So how this works, at the reactor's anode, water is oxidized to generate protons that are transported by the membrane and used in further reactions. The catalyst reduces gaseous CO2 into molecules such as carbon monoxide, methane, and ethane. So this will reduce the carbon dioxide that gets released into the atmosphere. So another cool fact is that Opus 12's technology may be useful for converting an abundant gas into useful chemicals on Mars or the Moon. So that's another cool fact about this. So yeah, that's my extra topic too.